Welcome, everyone, to today's Passive House Alberta Building Better in Alberta webinar series, sponsored by the Alberta Eco Trust. My name is Frank Crawford, and I am the Education Committee Lead for Passive House Alberta. Today, we'll hear from Tomaz Stich, a certified Passive House designer and certifier, and the Principal of Stich Consulting and Design, about some on-site monitoring of an earth tube system and cost comparisons to electrical HRV preheat options. First, I'd like to thank the Alberta Eco Trust for their ongoing support. It is very helpful in allowing Passive House Alberta to continue our work. As always, you can place your questions in the chat box, and I will ask them at the end of the presentation, or you're free to unmute and ask them yourself at the end. And with that, now please take it away, Tomaz.
Thank you, Frank. Good day, everybody. So I'm going to present our earth tube that we installed in our house in 2020. In 2020. And I had data loggers applied to this earth tube, so it's real-time data, which I will present now. Okay, so quickly to myself, I'm a structural engineer from Germany, certified passive house designer and building certifier, and passive house course provider, founder of Stich Consulting and Design. And what we do is mainly we supply, plan, design passive houses in CLT, wood fiberboard installation, and passive house certified windows and doors. So if you're interested, give me a shout. All right, so I will present basic principles of an earth tube system, system components, design consideration, advantages, risks, and I will present measured data as well, and compare it with other systems, and one example of the energy that you save with an earth tube. So let's dig in. So a geothermal air-to-air heat exchanger called earth tubes uses a stable ground temperature to precondition incoming ventilation air. So this ventilation air is connected directly to the ventilation system. The outdoor air is routed through buried pipes before entering the building, and you can use it for preheating or pre-cooling in summer. So primarily, how it started was they used earth tubes in Germany for prevent freezing of the HRV heat exchanger in cold climates. This is how it started. But then, it went on, and so they use it for preheating and pre-cooling as well. So of an earth tube is, can you see my cursor, Frank?
Yes, I can.
Okay, so if you have a building here, HRV inside the building. So on the left-hand side, you see some different schematics of earth tubes. It can be 2 pipes, 3, it can be 1 pipe. It doesn't have to be around the house, it can be 1 pipe. It has to be installed under a slope. And at the lowest point, you should have a condensation discharge just to prevent mold and condensation. Okay, so system components. You see some plastic piping here on the left. So typically, this is what's buried underground. This one here is a HDPE pipe, high density polyethylene, with elbows, Ys, couplers, or you can use a PVC pipe as well. Those here on the right-hand side are metal piping, which is you have a condensation drain here at the lowest point. You have a shutter here, and this is your air intake on the outside. Okay. So the depth of your earth tube should be below the frost line. Deeper preferred, of course. Ours starts at 10 feet and then slightly slopes up. The length should be minimum 100 feet. Slope around 2%. So if you have connected in summer, the water can run down to the lowest point where it can be released through the P-trap. The sealing of the different tubes through gaskets or sleeves. Gaskets are usually enough. We use sleeves as well, as you will see later, just to prevent like pressure of the water. Material should be food safe HDPE, high density polyethylene, or PVC. It should be smooth on the inside, of course. The air intake, real mesh diameter should be more than the HRV intake, which is typically 160 millimeters. So we used an 8-inch, which is 200 millimeter pipe for the earth tube. The planning tool, so I didn't use the planning tool, but there is one planning tool which is called pH Luft. It's only in German so far, and I will show a screenshot of it. The standard that handles ground source heat pump. It's the International Ground Source Heat Pump Association that handles earth tubes, but it's only closed loops, so dealing with glycol, right? So this doesn't apply to air-to-air earth tubes, all right? So here you see a screenshot of the pH Luft. So on the left-hand side, you have you pick what kind of soil properties you have, the density, thermal conductivity, temperature, temperature, how I would translate that, conductivity, and then you have your airflow, your depth, your groundwater level, and some more properties of the piping. And then you would get a screenshot like this here, where you have your interior and exterior temperatures. You have your air that is supplied to the HRV, which helps, but it's still an estimate, right? So when we installed our earth tube, we didn't use that one. We didn't use anything. I wanted it, so we did it. And it turns out to be very cost effective and practical. So the advantages of an earth tube reduces heating and cooling energy demand. Operating costs are zero. They are pretty much maintenance free, except cleaning every, I would say, 10 years. It provides preheating and pre-cooling, and it prevents the heat exchanger from freezing in winter. So the HRV units that are used in passive houses are passive house certified. So it's different than Home Ventilation Institute. They don't have a defrost mode. This is why an earth tube is really handy, because the electrical preheater in the HRV or ERV doesn't turn on at all. So limitation and risks, high groundwater level, which we just experienced in a project in Springbank, is a problem. So high pressure and high groundwater can be a problem. Cleaning can be difficult, but usually every plumbing company has its tools to clean it. Excavation costs versus electrical preheating. The effectiveness of the earth tube is very much depending on your soil depth and length. Moisture mold risk, this is the main disadvantage that always comes up with earth tubes. And I agree it can be a problem depending on the location. We are in Immermeer, which is a very dry climate, so we don't have problems with moisture or mold at all. There's no quick boost mode possible. It's always it does what it does, and it's not comparable with an air conditioning unit. Okay. So coming to the measured data of our house. So on the right-hand side, this is our house. It's 202 square meters treated floor area, structural slab on grade. We have a frost skirt in Invermere, as I mentioned before. Heating degree hours are 112, and we use a Zender Q350 ERV with 86% heat recovery, and the air flow rate is 180 cubic meters per hour. So we used a HDPE pipe, type ADS N12, 8-inch diameter. Length is 100 feet. So here, and you will see some pictures right now. So this is the air intake. This is a screenshot from my production model. So this is the lowest point here. It goes straight down and then slopes up until it reaches here, the mechanical room. Okay, so we start at 10 feet depth and then sloping up. It's a screenshot of the main floor. Here's the air intake on the right-hand side. Goes all the way, and then from here on, it's really warm under the slab. So this is how it looks on site. Typically, the earth tube is done while you're excavating. So this is when we did before we did the slab on grade. So it is quite a bit of excavation required. So here you see the lowest point, and then slightly sloping up. And this is where the mechanical room is. So this is when it's installed. So this is around 10 feet. From here on, it's sloping up, coming around. And this is the air, or this is where it's going to be connected in the mechanical room to the HRV or ERV in this case. So we used, so there are gaskets between the components here, but we taped it as well just to be sure. So this is the air intake, where it comes to the into the mechanical room. And yeah, so here we have the slab on grade. So this is the air intake, and then it goes down and then slopes up here, goes around and comes in here. So this is after the so this is before the concrete, and this is after the concrete. So this is the air intake. I placed the data logger here. And I placed a data logger in the mechanical room. This is the Zender unit. So this is a clean out. So there's a data logger behind that one. So, and what I did wrong was I saved the settings in the data loggers every 10 minutes. That's a lot of data, which is good, but it's almost too much to handle. So this is just from 1 year. I had it for longer, but I thought I'm going to show you this one here. So this is from August 21 when we moved in to August 22. So you can see the temperature here, -30 in wintertime. And this is the interior temperature. So when I say interior temperature, I mean the temperature how it arrives at the HRV unit or ERV unit. Okay. And from there on, it's warmed up. So just to keep it simpler, I produced two sheets, one that measures the data from 1st of December 21 to 31st of January 22. So the blue line is the ambient temperature outside. Or sorry, yeah, those here. And then this is the basic line, right? So we had minus 30 was the maximum exterior temperature or ambient temperature. And so the max delta T was sometimes in December 21. So we had 38.6 degrees Kelvin, right? And this is the maximum or the minimum interior temperature, 2.91 degrees Celsius. This is how it came in. That was the minimum, right? So, which means the preheater that we bought built into the HIV unit never kicked in. So the preheater of a Zender unit kicks in when the temperature is lower than minus 5 approximately, and then brings it up to 0. Okay. So, and this is what is very often neglected. And in my opinion, it's the biggest advantage in summer. So July 1st till 10th of August, we had a maximum inside temperature of 19 degrees, which is pretty sweet if we have 43 outside, right? And the minimum temperature was 14 degrees. So delta T at this point here was 23.8 degrees Kelvin, which is pretty sweet in summertime. So coming to some calculations. So I calculated for December and January the equivalent preheater that would have been required to preheat the air to this temperature. So that's the formula, M being the mass of air, Cp specific heat capacity of air, and the delta T based on the numbers that I just showed you. So this is the mass of air, this is your specific heat capacity of air, and this is my delta T in average. So that's 3,291 kilojoule per hour. If we convert this into kilowatt hours, it would be 0.914 kilowatt hour per hour, right? So if you run this 24/7, so all day in winter, 0.91 times 1,440 hours makes 1,316 kilowatt hours for December and January. At 13 cents per kilowatt hour makes $171 for December and January. Okay. So, and now another example, energy of the preheater that Frank has built into his house. So he gave me the total number per year, which is 477 till 593 kilowatt hours for the year. So, which basically means the heating season in winter, right? So this one kicks only in if the temperature is lower than -5, approximately. So the Q for the fans, 30 watts. This is what they need. Multiplied by the days and hours is 262 kilowatt hours. So if we subtract this from the total cost or the total kilowatt hours, sorry, we get 215 kilowatt hours or 331 kilowatt hours. So multiply that with 0.2 cents we get to 43 or $66 for the whole year or the heating season. Whereas I have to say that delta T is unknown and it's only till zero, right? So you don't get um, yeah, 10 degrees or 12 degrees Celsius. So the cost for a preheater is about $500 built in, only to get the air to above zero. Whereas the cost for an earth tube install is about 2,700. Okay. So our material cost for our earth tube was $1,500, and that's in 2020. Excavation costs and installation was about 1,000 to 2,000, 1,200 Canadian dollars. Um, the built-in preheater, 1.5 kilowatts, never turned on. The heat exchanger never freezes. Um, and we have 24/7 ventilation, so no defrost mode. Remember, if you have a HVI certified unit, it has a defrost mode. Every time it kicks in, there's no ventilation, and it's only yeah, running the stale air through the heat exchanger in order to defrost it. Okay. The interior room temperature never rises above 24 degrees during the summertime if the family members don't forget to operate the exterior Venetian blinds. Um, yeah, and then last but not least, I have a comparison with other systems. So other systems, instead of earth tube, would be geothermal closed glycol loop or ground probe, integrated HIV preheater, which operates until minus 15 degrees Celsius. After that, it shuts down, or the heat exchanger freezes. Or you install an additional electric inline heater before the incoming air goes into the HRV or ERV. So each of those has an installation cost, which can be relatively high. The additional electric inline heater is pretty low, but there's always energy required, right? They're all, how should I put it? They're all mechanical units that can break, which and has to be replaced at some point. Whereas the air-to-air heat exchanger or earth tube doesn't have any mechanical moving parts, right? And yeah, that's about it from my side. Frank?
Yep, excellent. Thank you, Tomaz. All right, one or two questions. So back to the photo. Um, what are we bedding the earth tube itself in? Is it just like washed rock or concrete or sand or what should we be bedding this in?
I go back. So this is sand or gravel, I should say. Um, this is how they laid it down or bedded in. Yeah.
Yeah. And do you need much compaction or just make sure it doesn't settle
No
together? Yeah.
compaction, just sit on top.
Yeah. I guess you want to make sure there's no low points, but yeah, you don't need to tamp it or anything.
No, 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 no.
Okay. Um, I guess another question, if we're because you just went underneath the slab and the slab is fully insulated. So if we're going maybe a foundation wall or a basement, is there like a specific distance we want to be away from that foundation to not kind of steal heat from the foundation to heat up
But
the
you
tubes?
want to steal heat from the foundation. That's
Well,
the whole, yeah.
okay, so close to the foundation wall isn't a concern if it's a basement, or do you want to stay a foot or two away?
You can stay close to it. Yeah, no problem at all. Well, we went under the slab, right?
Yeah.
Yeah. So it doesn't matter where. Under the slab, it's warmer, or it's more stable, the ground. So this is what you want, stable ground.
Yeah. Question about septic fields. Do we want to stay away from septic fields, or do we actually want to maybe be closer to septic fields and steal some of their heat?
Exactly. If you have a septic field, you can go close to it, because you can steal the heat. Yeah.
Again, I guess following the next question, if we're going near the septic field, make sure you're maybe sealing and taping and
Yeah.
gasketing or
Yeah. Yeah.
using,
Yeah. Well, the gaskets and the sleeves are always a concern, especially if you're next to a septic field.
yeah. I've seen in other reviews that if you just use the like 100-foot roll of non-perforated weeping tile, then you have no gaps. But do you have more air friction in that? Do you need more pipes? I guess maybe different
Um,
types of
I
pipes.
I don't know what material it is, and I don't know how the weeping tile is on the inside. So that would be the problem, I guess. And I don't know what diameter you get it and to.
Yeah, and I guess any off gassing you want pipes that don't off gas because you are filtering
Exactly.
that
Yeah, it
air.
should be food safe.
Okay, so that's probably not weeping tile.
No, probably
Um,
not.
so Joseph said says some good Enercan resources. Nice. Yeah, because another question. Do you want the reason you are oversizing the pipe is so you're not overtaxing the fan, or are you maybe how do you
Exactly.
talk about the fan size and such?
Yeah. So you want a bigger diameter than the ventilation intake, so the fans don't work harder than they should.
Yeah, so try to oversize it as much so that the
Yeah.
friction doesn't enter. Okay.
Exactly. Exactly.
I guess, and maybe to filtration, are you still relying on just the MERV 13 filter in the Zender? Would you, if you did it again, would you maybe move the filter to the other end of the pipe? Do you have filters at both ends? I guess talk about filtering.
Okay. So we don't have any filters. The filter is just the incoming, it's in the Zender. There's an exhaust and a supply air filter. So this is what we use. And there's a mesh at the air intake, just to prevent critters and, yeah, animals going into it.
Okay. Like with the increase in like smoke and smog, do you think maybe a like a MERV 8 or something filter at the incoming might be a good idea? Or
Well, we have sec find this picture here. So this part here, this is where this one goes in if we have wildfires. So that's a charcoal filter, and that works perfectly fine.
yes, yeah, yeah, it's filtered there. Okay. I guess I was just
Yeah.
wondering more to try to keep the pipes cleaner. Do you want to filter more at the beginning to keep the pipe clean?
It's just air, and there's no dust, or not typically not that much dust outside. So you can build in a filter here, but it should be, yeah, you have to size it properly, right? It can't be too fine. So that might be a problem. If it's too fine, that the airflow is not guaranteed.
Okay, good. Yeah, it looks like there's an example in the Eco Solar Home Tour. I believe one in Edmonton that's got an earth tube. I believe you're on the Eco Solar Home Tour as well, Tomaz? Does that one have an earth tube?
No, that was the problem that I mentioned. They have very high groundwater, and it filled up right away. Um, so they yeah, said no, we're not going to do it. And that's the Calgary Eco Solar sorry the Eco Tour of Russell and Sarah. It's going to be on the 20th of June. Yeah, it's a
Yeah.
passive house, CLT, wood fiber board, passive certified windows. They have everything. It's just not the air tube.
Excellent. I guess can you talk how, because the mold concern is a valid concern, maybe not, maybe less so in dry Alberta, but more so in wetter climates. Is there a way to reduce it or clean it?
Um, well, you can take off this part here, and you can. It's not the nicest part, but typically they clad the whole thing somehow. So you take off the gooseneck here, and you can take off this here, and then you can clean it with a special tool, or any plumber has a tool for it to clean it.
Oh, the water or the vacuum tube just goes into
Not
the
even
pipe.
water because it's bone dry.
Okay.
So what I didn't do is to install a P-trap at the lowest point. But that was just because of um, nature of building. So the excavator was nervous already, and so I said skip that. So I taped everything and closed it up. But what I do every 2 or 3 years, I take this one off and put something down and check if there's some condensation, which hasn't been there yet. It's bone dry.
Good. So you said below frost line, so in Alberta, probably at least 8, 10 feet and lower the better.
The lower the better. Yeah,
Um, could
exactly.
this be used? Could this be used for, I guess, a livestock or an animal building to kind of preheat for other things?
You could. Odors and smell might be a problem there.
Yes, yeah,
I
you always
could
make sure.
imagine. Yeah,
Yeah, yeah.
but
I've seen earth
from
tubes used for for other uses into passive solar
yeah,
greenhouses and stuff like that.
yeah. But as I said, 100 feet, everything that's longer, it's like too much, and or it doesn't do a lot anymore. So, but maybe use the planning tool, the pH Luft, um, which is a good tool. But you have to know your ground, right?
Yeah, it definitely depends on the soil.
Yeah.
Maybe talk a little bit about. So you showed that it was very good at doing kind of preheating of the air in the winter, but maybe talk a little bit about the pre-cooling in the summer, and which seems to be a growing concern. And then I guess the only time that it maybe doesn't work ideally is maybe the shoulder seasons because there's always a lag. So would you ever consider putting in like I guess a bypass so that you could bring straight air from outside if you wanted, but most of the time go through the earth tube,
Well,
or is that just too complicated?
it's not too complicated, but you already have a bypass built into the HRV unit. So you just have to turn it on.
Yeah, actually, yeah, sorry. Why don't you explain what summer bypass is in PHI
Um,
certified ERV versus other ERVs?
I don't know how bypass works in other HRVs or ERVs, but at the Password certified ones is basically when you have colder climate inside and it's warmer outside, you bypass the heat exchanger. So when when the oh sorry when it's um so you bypass the heat exchanger by not heating up the incoming air that's in the shoulder seasons. Um, so when the air comes in, it doesn't go through the heat exchanger, so it goes straight into the house. You bypass the heat exchanger, depending on what temperatures you want and what the ambient temperature outside is.
Yeah, yeah, and to as far as I've been able to find, none of the kind of lower cost HVI certified HRVs or EVs have that bypass option.
Okay, yeah.
It's only once you go to the passive L certified ones that you get that summer bypass, which I think is becoming a pretty good advantage because you get to be able to
Oh
use
yeah,
that
definitely.
pre-cooling, especially on an
Yeah.
earth tube.
So when I turn on the bypass at the Zender, it's about 4 to 5 degrees difference. How warm the air comes into the house or into the HRV or
Yeah. Yeah.
behind
He
the
says it's
HRV.
not,
Sorry. Yeah.
yeah, it's not, it still doesn't replace air conditioning, but it can definitely reduce the amount of times you need it, or I guess passive survivability is becoming fairly important. So this is another example of a way to get some more passive survivability.
Yeah, definitely for sure.
Question from Joe again. Have you seen any applications where instead of supplying makeup air, they're supplying an air source heat pump?
Um, routed into the HRV.
No, I think it's asking, could you use earth tubes to provide enough air for an air source heat pump?
Oh. That's a good question. I can't answer that because I don't know how much air an air source heat pump needs. But from a technical standpoint, it should be possible. Um, but that would be, I mean, if I look at the fan of a heat pump, it would be a pretty big pipe that you have to supply.
Yeah.
So I
Yeah.
don't know if you make the fan work too much. I don't know.
Yeah, I think the only specs remember seeing is that it moves up to 2000 CFMs of air on the outside air source heat pump on the coldest
Okay.
days.
Yeah.
So yeah, that would be a lot of air moving. I think,
Yeah.
yeah, use an air source heat pump with the air, use a ground source heat pump if you're going to use the ground.
Yeah, and I guess the flow is way too fast. So you can't drag it too fast through the ground because then you don't pick up any heat, right? So and 2000 CFM sounds quite a bit.
Yes. Yeah, just go ground source where it's designed to move fluids underground and into the heat pump.
Yeah, yeah. So another very good option is, but that has nothing to do with ventilation or preheating. It's a ground probe where you go deep, um, and a water-to-water heat pump. So this is what my parents have in Europe, though, but it works very, very well, and it works day and night, if you want to or if you have to. Uh,
Good. Chris gave us a link to actually Woofy, so PHI US. Woofy has a tool also that I guess can help you design these earth tubes. That's nice.
yeah, I don't work with Woofy, so I don't know that.
That's fair.
Um, yeah.
Kim's question, would you consider adding insulation over the ground loop outside of the foundation? How about a metal shield over the earth tube so that in future excavation, you know it's there and don't hit the pipe?
Yeah, in our case, it's in the backyard, so we know where the pipes are. It goes straight down. Insulating the upper part or above ground doesn't do a lot because um, the insulation gets cold because it's on the outside, and so it's just a matter of time until the insulation is as cold as the inside. So it doesn't do anything.
Okay. If you can't bury it deep enough to get below frost line, then don't bother, I guess.
Then don't bother. Yeah.
Okay. Um, do you want to explain kind of the HVI defrost mode versus the PHI HRV defrost modes again? Just make sure some people weren't clear on that.
Okay. So the pass for certified units, they don't have a defrost mode, which means the heat exchanger can freeze. Whereas the HVI units, they have a defrost mode where a lever kind of stops the incoming air, and you router your stale air from inside the house through the heat exchanger to defrost it. and then back into the house. So during this time, you have a higher energy consumption. You don't have fresh air, and you don't have um, um, heat exchange or energy savings, right? So this is yeah, this is the main reason.
Okay, thank you. Rob's asking a bit more about is there actually a calculation for how long the earth tube needs to be, or do we just say at least 100 meters and longer if possible? Or is
Well,
that,
again, you can use the I guess the Woofy software, or you can use the pH Luft to calculate or to get a rough number. Other than that, to keep it simple, I would say everything that's longer than 100 feet doesn't really do a lot anymore. Um, so 100 and as deep as you can. That would be my recommendation.
okay?
But
Um,
again, it all depends on the ground.
the- can it be, can it be, so the question is, any concerns if you have more than 2% slope?
No, no, no. It's just minimum 2% slope.
Yeah, you want the water to go to a drain,
Exactly.
so
Yeah, that's the main reason. So
steeper would be better. Would it be best to put the drain closer to the house or further away from the house?
it depends on your topography of your ground. Maybe you have the house higher up. Then you could grab it from the bottom, um, or vice versa. So it depends. Our lot was pretty flat, so we didn't have this problem. But yeah, it depends.
Any concern with the P trap or being able to, or the drain, the condensate drain, allowing radon to come back into the earth tube?
No, because the P trap should always be filled with water. Um, or there, how should I put it? Let me see if I find the picture. Um, yeah, there are like how do they call it? P traps that have a ball. So
The
there's
dry ball,
no,
yeah.
yeah, exactly. Um, so there shouldn't be any risk of radon coming into the P trap.
Yeah, so I guess similar to an HRV's P trap, which is normally a dry ball type,
Yeah, yeah,
you could use that
exactly.
same P trap here to even if there is no moisture, then the radon wouldn't come back
Yeah,
in.
exactly.
Good. Do you want to go back to that costs 2 pages again? So it looks like depending on how expensive the excavation is, the payback is still a number of years, but you have a lot less moving parts. And if you can get the
Yeah.
excavation costs down, then the payback would be quicker.
Yeah, of course. I mean, this is just an example from our house. So in Calgary it might be different. Um, and we haven't talked about the summer conditions yet, right? So I think in summertime it makes really the big difference. Um, and this is not captured at all here, right?
Yeah, that's only the
So
heating. So adding the cooling
exactly,
in would be good. And being able
exactly,
to having a good enough HRV, being able to take advantage of that free cooling in the summer.
exactly. Yeah, right. I mean, I don't have any concerns at all. The earth tube works perfectly fine at our place. And I invite everybody who's in MMR, just knock on the door. I'll show you everything. Um, yeah,
And I guess if the earth tube is going underneath your foundation, just check with your structural engineer that uh, they're okay with it, but it should be a small enough. Um,
yeah, but even if it's under the foundation, you have one point where it goes in. And this is basically the structural part, right? All the rest, I don't see a concern there. And
Okay.
if you ask a structural engineer about an earth tube, or the weight or the yeah, the load that comes down on the wall, I don't know. It might be a funny result that comes out there.
Yeah. Another piece of rebar so above where the trench is if you're concerned.
Maybe, yeah, but yeah.
Yeah.
So we built with CLT, so I don't have any concerns there.
Anyone want to unmute and ask any other questions? I think I've got them all. Lots of good questions today. Thank you.
Yeah.
Let me see. No, I think it's all on the list. We are done a little bit earlier today, but thanks. Thank you, Tomaz. That was very informative. Yeah, I guess last call. Any other questions or any other, I guess, ventilation, HRV, yeah, certified passive house certifier on the call. If you have any other questions, feel free to ask them now. We still have a few more minutes.
Hey Frank, it's Kim.
Yep.
I'm not I wasn't here at the beginning to see if this happened, but I just wanted to say that thank Tomaz for doing the presentation, and also to mention that this presentation is similar to one that was done by the Passive House Canada Pulse event in Calgary a few months ago, and that people should be looking for the next Pulse in Calgary from Passive House Canada.
Tomaz, you want to go back to your contact info again in case anyone wants to get in touch with you?
Yeah.
Yeah.
Um,
So a question: is there an ideal soil type for earth tubes, or can it work anytime, or is there an ideal?
I guess, yeah, clay, I don't know. Um, I don't know. You have to play around with the software to find out the thermal conductivity of different ground materials, and go from there. And it is what it is. I mean, if you have a lot, you won't pick your lot based on the ground in order to install an earth tube, right? It is what it is when you buy the lot.
Yeah, yeah. If you don't have great conductivity, you could try to make it longer or
Yeah,
deeper.
yeah, yeah. You won't change all the material on the
No.
lot just to have more thermal conductivity, right? Um, yeah, and then I would like to invite you to the Eco Tour on the 20th of June to the Springbank House. It's on their website. I will be there as well. It's a very nice house. And yeah, the builder will be there and the owner will be there. So you have lots of opportunities to ask questions.
Excellent. All right. Any other comments? If not, then yeah, I'll end the recording and thank you all for coming this. So for the Alberta, the Eco Solar Home Tours, there is no registration. So if you just go to ecosolarhometour.com, I believe is the website. Maybe someone can throw it up. And the Edmonton is one weekend, Calgary is one weekend, and they just give you a list of there's about 10 buildings in each city, and there's a time frame for each site. So there is no registration. You can just show up, plan your route on Google Maps and hit a bunch of them at a time. Yeah, there's the link in the chat. And yeah, there's a number of excellent passive house, near passive house, high performance homes on that tour. So yeah, it's an excellent time to see in practice and in 3D in real life what we've been virtually talking about.
I just want to mention the house in Springbank is CLT and wood fiberboard. So if you want to see something different, that would be a good opportunity.
Yeah, and is that all imported from Europe?
Yeah, it came from Austria. and it was prefabricated, so one wall was one panel, basically.
Nice.
Yeah.
Good. Alrighty. Well, I think that is it. I will stop the recording and thank you all for coming.
All right. Thank you. Bye.